well, welcome back. So our next session is on demystifying buzzwords. We've all heard them, and now we'll take a turn and better understand what they are and why they are important so that we can apply them and make sure that we're moving forward with our data appropriately. To help us do that, we have Bryan Baird, who is an applied data science lead for our public sector team. Bryan.
Great. Thank you so much, Patrice. Hello, all, and welcome. As she mentioned, my name is Bryan Baird. I'm an applied data science lead in our public sector practice here at Civis Analytics. And I'll be talking today a bit about buzzwords. Everybody knows and possibly loves some of them. This will be some of the ones that we see a lot in the data science space, especially with government and public sector work. So as a general session overview here, we're going to talk about how some of these common words that we see a lot in this space relate to each other and how they might relate to your organizational thinking in terms of what are the parts that you might actually want to care about, what are the things that you might be trying to articulate when you're not sure if a buzzword is the right way to describe or define that, and really how you can carry those conversations forward. This is not meant to be a super comprehensive or in-depth or detailed session. It's not meant to be a particularly serious session, as you may pick up from some of the different buzzwords that we will go through here today, but do hope to give a bit of a practitioner's perspective, as well as from working in the industry here and with a lot of our government and public sector clients, what are the ones that we see come up a lot in this space. And so really the framework here boils down into a few different problem set groupings that I think are very relevant. So first is the idea of which of these things correspond to broader disciplines. You know, a lot of this we'll get to Owen's session from earlier in the morning about building up your public sector data team. Then there'll be some brief mention of technologies. There are far too many technologies to fit into any 30-minute session, but we will make a valiant effort. We'll talk a little bit about some of the methodologies that come into place. And then lastly, we'll end on a few notes about sort of the management practices to drive engagement. So with this, it feels like we need to start with the big obvious one, which is, what is data science? It's very easy to use this as a buzzword and a term throughout any sort of big conversation without nailing down a concrete definition. And I'm not necessarily going to give a concrete definition, but I do want to highlight some of the things that or threads that you maybe noticed from the earlier presentations as well. Data science really is about this organizational problem solving, and it covers such a wide spectrum of different outputs. It can be both about the specific data insights that you get from singular analyses, but it can also be about building products, data products, whether those are maintained or one-off. That kind of output design is also something that falls under this broader discipline. It really is end-to-end at its broadest point, all the way from collecting and thinking about the raw source data through the ways that you process and standardize it, as Iñaki and Tasmio were just talking about, the analyses, and importantly, the communication as the last step. Data science really does involve connecting with the right experts and sharing your insights out to a different audience. So with that in mind, it's a very multidisciplinary spanning field. A lot of different backgrounds come into play in data science, not just computer science or statistics. Where that as a discipline can relate to some others that you've maybe heard of, these are, again, all fairly blurry lines. This is nothing concrete here because they're buzzwords, but frequently when we hear data science in the space, it's used to differentiate more towards predictive applications. So programming and modeling and trying to understand something about using statistics to predict something in the future. Data engineering, as Owen mentioned, is a closely related newer discipline to data science, which is really just about the efficiency of moving that data from the place that you get it to the place that you need it, accounting for quality, storage, moving those things around effectively. It's very important for empowering a lot of other disciplines, and whether or not you have a data engineer on staff, somebody is probably doing something like data engineering. Slightly separately, when you hear analytics or business intelligence, this can be part and parcel with data science, but sometimes it is used to be more historical explorations, general data visualizations, looking at trends, and a lot of database queries with something like SQL, SQL, the query language. So in terms of data engineering in particular, I want to drill in on a couple of the different technologies we hear about a lot, especially in the public sector space. So there are two that come up very, very frequently when we talk about working with, storing, and organizing data. And there's the great debate between a data warehouse and a data lake. So strictly speaking, a data warehouse is supposed to be a much more organized database of relational tables. So it's got rows and columns. It's that structured data that was being talked about earlier. This means that a lot of the effort goes in upfront. So you clean, standardize, decide on rules for the data when you first receive it so that your output is very neat and orderly and has a lot of rules you can count on. This makes it very well suited for reporting and business analytics cases because people can use the output data without necessarily needing to worry about the full stack of where it came from. A data lake, on the other hand, flips that and says it's a lot of work to structure the data up front, and not all data types are particularly suitable for really structured data. So you can have text or images in that as well. Puts more of the emphasis on search and discovery. So there are search features or tags or other ways to find the data sets or data artifacts that you care about. And that means that there's less upfront work that's strictly required. That can make the data harder to work with. You're potentially giving fewer assurances of what is definitely in there, but it can also be suitable for a couple of different applications. One is for advanced machine learning. There are some AI practices that we'll talk about in a second that don't necessarily work on structured data. But sometimes it's just a way to share general files, and you don't necessarily want to invent a whole rigorous system for just getting the type of data artifacts that you're trying to share. Now, these two, you might notice, are not really mutually exclusive, and increasingly we see a lot of people trying to get the best of both worlds. And I think there are parts of that that make a lot of sense. It is one where the buzzwords and the metaphors kind of quickly break down, but we'll hear a lot about, well, a data lake house or something that tries to get the search and the storage. I usually recommend trying to not find an overly clever label for that, not the least of which because a data lake house is not a data warehouse that is a lake. It's a house near a lake. And it just gets very confusing to try to over-engineer a clever name. I think it really helps to focus on the use cases more and what you actually need. With that in mind, how does that data actually get moved around, whether in the data lake or to the data warehouse? The very precise term you'll hear is ETL, or exchange, or extract, transform, and load. This is an older term, a very formal term for how to move the data from one place to another. That's everything from how you actually connect to where the data currently is. You make a copy to the system where you need it. You do any of that reformatting or data cleaning in order to get it in the format that you need, and then you save it. We talk a lot about data pipelines at Civis and at other practitioners and data engineers in the field. Data pipeline is just really a way of thinking, how much of that process can you automate? How much can you make it so it's not somebody's job to go check an Excel file every week, copy paste the latest updates, and then try to update something else from there? If you're moving a lot of data or you're moving data very frequently, having a pipeline is something that's very encouraging to know. You're going to keep getting the latest data in a nice, reliable format as soon as it's available. So with those sort of backgrounds in place, I got to talk about the next great big buzzword, which is AI. And really wanted to lean into the campy clip art for this one because it is a very buzzwordy buzzword. It can encompass a lot of different things. Of course, all the way from the super sci-fi to the very, very mundane in terms of day-to-day applications. But it's not surprising when people hear about things that are done to get some themselves. I think it can define, frankly, too many things. And so we want to focus in a little bit on what are the more practical parts that we usually see. So this is where the idea of the methodologies come into play. AI, or artificial intelligence, is the very broad description of just computers that can learn and ideally intuit in some way how to make decisions about things on their own or with minimal human intervention. In terms of what AI looks like in practice is machine learning. So machine learning is one particular kind of AI. It's the one that has been probably the most rolled out and most practical in recent decades. And that's just generally this idea of computers can learn how to find patterns in data and expand upon them without you needing to explicitly program what that pattern is. I'll show a little bit more of this on the next slide. So within ML or machine learning, you'll hear about algorithms. That general idea of you put in some data and you get some rules out, there are a lot of different algorithms that can work well for this, specific statistical tools or software packages. Some of them become very popular for a while. Some of them are very well suited for specific programs and problems, but not others. Categorizations within this of supervised or unsupervised. But this is essentially how do you pick which of those many, many tools that are available are the ones that will get you the best results for this particular machine learning problem. And then lastly, as I mentioned at the start, we often hear data science strongly associated with the idea of making predictions, forecasting, looking forward. So a predictive model is something where you are taking one of these ML algorithms that you have trained or set up, and then you are using that to make predictions about something in the future. So these are the kind of shrinking concentric circles of these concepts. There are plenty of other things that might be considered AI in the future. There may be whole fields of AI that become very popular that don't look like this. But I would wager at least more than 80% of the time, when AI is the buzzword that you mentioned, machine learning is the practice actually being rolled out. And within that, there's a relatively small number of ML algorithms that really get practically used. So how does this model training or scoring aspect look? This is a fairly basic concept in terms of how the different pieces fit together, but it is different from how you might think of working with data in a more general analytics sense of just looking at basic summary reports or SQL queries. So the model training is you take the data, you specify some parts of the machine outcome, and it will generate the model. You put the data in and it figures out the rules that make the most sense. That is what makes it machine learning. It's figuring out most connect A to B when you know both A and B. Scoring is the second part of that makes it a truly predictive model, which is, okay, well, we have this pattern now. We have this set of rules that are algorithm made, and we have some new data where we know A, but we don't know B. Now you just combine those and you get your best guess at B. The thing I always want to emphasize here is that they are predictions, they are guesses, they are hopefully better guesses than you would make without the model, but that is usually what you're trying to get at. You are trying to beat your intuition and identify some things based on patterns you've observed in the past. Separate from methodologies, there's a very different question about how do people actually use the data and outputs, and how do you build that kind of trust? So here are some of the words that we hear from that. Data governance comes up a lot as another very broad term that covers a lot of different things. It's a whole set of practices and processes, everything about who owns which data sets, who's responsible for certain different types of maintenance, formally who is allowed to have access and not. And to figure out the right people can see the data, and especially when you have private or secure data, you're controlling that access appropriately. It doesn't always come up, but it is one that is fun to hear about. This is when you're trying to describe holistically what was the whole journey that the raw data took to the final thing you're looking at in the output. This can be a very complex proposition depending on what you're doing and the data that you're working with. And so in the ideal case, you can trace all the way back from the report or the dashboard that you're looking at the end to the raw Excel file that it came from 6 months ago and know exactly what that data is. But anything where you're trying to establish that connection and better understand where specific data points came from. And then a data catalog, you'll also hear mentioned in a lot of contexts here within data governance of just the tools, the warehouse or the data lake, the ways you're storing this data are not necessarily going to be for all different people that might be interested in using that data, especially those who are not already familiar with the specifics about a data source. So the data catalog is just a way of listing out things you could want to know about the data sets that you have available. So finally, another one that is definitely in the buzziest of buzzwords, the idea of big data. This definition is a bit of a moving target because it is in many ways defined by the scope of the challenges that are available and the scope of the technology that currently exists to deal with it. Big data is a very subjective term. There are lots of people who have written very detailed, formal definitions of big data in different tools. From a practitioner's perspective, usually what big data winds up needing is that you have enough data available that you actually need to worry about how you're storing and moving it when you're trying to do analysis. And that sounds like a kind of squishy, hard to define figure. It's because, again, it depends a lot on which technology you have available, which practices you already have in place. If you think of something truly massive like Google's search history, they have very different big data needs for processing hundreds of thousands or millions of searches every second, every minute. But what I really want to highlight here is in practical data use, and especially working with some public or government data sets, these concerns can creep in a lot smaller than you might think. So with that, I want to leave a plug here for two numbers that it says memorize. You don't need to memorize these numbers, but hopefully if you see them out there in the wild, they cause the hairs on the back of your neck to stick up a little bit. These two numbers represent the maximum number of rows that an Excel file can fit when you open it as a spreadsheet. So the 65,000 is for version prior to 2007, and then after that, they bumped up the limit to this 1,048,000. If you see a data set that you are working with in your use case that has exactly this number of rows, that is a good sign that actually there's more data out there or something got lost because your old process was working through Excel. And so this is where some of the big data ideas about how do you effectively move scalable data can creep in at, frankly, very small amounts. And it helps to start thinking about that intentionally as soon as you realize that this could be something that you need to care about. So again, you don't have to memorize these, but the next time you see this exact number in some context, it should give you a little bit of pause. So just a few quick parting thoughts here. Reality is messy, right? Working with real data, data from the real world, especially when you're trying to pull together data from different sources, that is actually messy. Buzzwords come to exist for a very practical reason, right? They are metaphors of all of us trying to grapple around some common language across different stakeholders and skill sets for something that is very messy on the ground. I think what can help is, when in doubt, really focus on not necessarily the buzzword or the tool, even if you think you have a good formal definition, but the use case. You know, really think about what you, your organization, your constituents, what they want, what it is that you're trying to accomplish. As we saw with the data warehouses versus data lakes question, the right tool for the job is probably going to be a little from column A, a little from column B, and some practitioners will argue forever if this means data science or if this doesn't count as data science. It helps to just not get too lost in that conversation and really keep the energy and focus on how do you define success and what looks like a good, successful outcome. So with that, include a couple of links here. I have to give a big shout out to my colleague, Ben Kirchner, who previously and identified some of these resources. When we share around the slides afterwards, if you're curious to read about a few more, I encourage you to go ahead and click through. But otherwise, thank you all so much, and look forward to hearing more from you throughout the day.
Bryan, thank you so much. I think you've covered quite a bit of real estate there, and we do have some follow-up questions. And you know, it's interesting that you were just talking about data lakes and warehouses, because the first question is, if someone is starting essentially from scratch, is it most important to have a warehouse or a lake?
I think that's a very good question, and I'll probably start a fight in some communities, depending on who you're asking. I think, honestly, when you're really just getting started out, you're probably going to be working with things at a level of detail where that distinction is not really fully baked yet. I think work with a tool that you're already familiar with and then kind of figure out where you're trying to scale from. I have seen it argued, I don't know if I fully agree with this, that a shared Google Drive folder counts as a data lake if you have Excel files in it. because it's searchable, it has the files, you can include other unstructured data. Sometimes that's all it takes. You don't want to get too far ahead of yourself. But otherwise, if you're looking for something that will scale up to medium-term use cases or a team of collaborators, data lakes are frequently easier to set up. Just be aware that they can cause some growing pains, especially if you're trying to think about how to bring in different types of collaborators who don't want to be so plugged into the whole data transformation process.
I think you bring up a really good point in that sometimes folks tend to go straight to the tooling as opposed to understanding what they are trying to accomplish and working with what they have first, understanding what tools, what features they need, and then going on to tooling, which kind of brings us to the next question, which is, in your opinion, what's the most realistic use that you've seen in the government space of AI or ML?
Ooh, so I think there was a question from an earlier session. We were looking for some examples of that. I do think that one of the things that ML prediction can do very well is allocation questions. So for scarce resources, if you don't have the chance to go to everywhere, you have a limited budget or something, how do you identify what are the most likely candidates that will respond well to something? Now, this is something that can be a lot harder to do in the public sector space, right? Frequently, governments have a mandate to take care of everybody equitably in a way that a private sector marketer might just be able to say, only go after the first 10,000 likely customers. I don't necessarily care about the rest. That said, there are definitely plenty of cases in public sector where that can still be valuable. You know, how do you identify where you're doing maintenance for different types of infrastructure things? There's a whole dedicated specialized field of machine learning for predicting that sort of thing. How do you identify where to prioritize scarce extra outreach if you have the general materials available for everybody, but you're trying to figure out where to knock on doors or where to really send your community outreach efforts. So scarce resource allocation is definitely one of the things I see again and again as a very well understood ML application.
Awesome. Thank you for that. And, you know, that we just had this question come in. Love to get your thoughts here on data marts.
Yes. So I have not personally worked with too many things that wound up being ultimately branded data mart, but if you continue the imagery of a warehouse as being something large and massive and very structured and all over the place, that can be very intimidating for somebody who's just trying to work with a basic subset of that or wants to know what really is the actual polished final version of something. There's a recurring joke in a lot of data science or data working spaces of how many different copies of something are titled version 2, final, you know, do not use or something like that. So a data mart is essentially the idea of you have some great filter or some amount of polished things that says, here is the subset of things from the broader data warehouse that are really clearly defined, easy to use, better documented. These are the ones you're much more likely to care about. You know, maybe you have access to the full data warehouse, maybe you only have access to this subset, but if you are a more casual user or somebody just trying to take the right data and go, can you filter down to pre-select those things for them?
Ryan, you have provided us with a lot to consider, but what you've also done is make sure that we understand what all of this means and can really think about how it can apply to teams as they're continuing to build and grow. So thank you so much for sharing your expertise today.